So here is the problem. Problem number 1. Let me read it. A ball with a volume of 120.3 milliliters contain 0.25 grams of nitrogen gas. Calculate the pressure inside the ball at 31 degrees centigrade. So this is the problem in the ideal gas law. So the ideal gas law is PV equal to nRT. So let me write that. PV equal to nRT. In this equation, P is the pressure, V is the volume, N is the number of moles of the gas, R is the molar gas constant, and T is the temperature in Kelvin. Right? So in this problem, let us see what is the item that is being asked. Look over here. The first thing that you really need to do is read it as many times as necessary to find out what the parameter that is being asked. If you look at it, you see that here it is said they calculate the pressure inside the ball. So the pressure inside the ball. So you may want to underline that, and then see what are the parameters given. Now the pressure inside the ball is, this is the pressure that is unknown. What about the other parameters? V, volume. Well, V, as you can see, is given. V is equal to 120.3 milliliters. Okay, and N is the number of moles. So let me, number of moles of nitrogen gas, because over here is a nitrogen gas. So how is the number of moles? Well, we have been given that it is 0.25 grams of nitrogen gas. So as you can see, I can calculate the number of moles if I know the mass of the gas, and then if we divide that by the molar mass. Now mass given is 0.25 grams, and the molar mass is of the nitrogen number of moles of nitrogen, and the molar mass is, that you know, is 28. So 28 gram per mole. So I'll just keep it over in this way. Now what you can do is you can cancel the gram and the gram. So N is 0.25, and this mole is really the denominator of the denominator. So the mole will be numerator, and we have 28. So this is the N. R is the molar gas constant. Right? R is equal to molar gas constant, and the one that we'll be using is equal to 0.082 liter atmosphere per Kelvin per mole, right? And the temperature is 31 degrees centigrade, T. Now that needs to be converted into Kelvin. So the relationship is 31 degrees centigrade plus 273.15, and then that would be the so that, when we sum it up, becomes, let me see, using a calculator. So this is our calculator, and let's see, we have 31 plus 273.15, and that equal to 304.15. So let me put that 304.15 K. So now we have the parameters, right? So what I can do is I can put those in this equation. Now the P is the one that is unknown, so we can calculate P is equal to nRT divided by V. So now I'll put the value N is 0.25 mole, and then we have to divide by 28, and that is the N. R is 0.082 liter atmosphere per degree Kelvin per mole. So that is another one, and T is equal to 304.15 K. Let me do this. Let me put it in a new line so we have more space. So P over here is equal to 0.25 mole divided by 28.082 liter atmosphere per K per mole, and the temperature is 304.15 K. So the divided by V is the volume, and the volume, as we have already gotten, 120.3 milliliter, 120.3 milliliter. So for the time being, I'm going to cancel this one because I have written work in the bottom, and we get some more space. So P is this. Let me cancel out the mole and the mole, and the K and the K. So I'm left with 0.25. Let me bring the 28 as a denominator, and I have 0.082 liter atmosphere and 304.15. Now 28, and then left is 120.3 milliliter. As you can see, we have liters in the numerator but milliliters in the denominator. So let me convert the milliliter to liters so we can cancel out this unit. We know 1000 milliliter is equal to 1 liter, so the milliliter and the milliliter cancels out, and then this 1000 being the denominator, we can either divide, put this 1000 on the top, or we can divide this 120.3 with 1000. So let me do 0.25, 0.082. Now over here, before I put the unit, you see the liter in the denominator over here and the numerator over here cancels out. Atmosphere is the only unit that stays, and then 304.15. Let me divide all of those. This is 28 times. I'm just dividing 120.3 by 1000, so that makes 0.1203. Right? And the only unit that remains is atmospheric pressure. So now these are all the parameters I have. Let me calculate the value using a calculator. So I have 0.25 times 0.082. I'm sorry. Let me go back. 0.082 times 304.15, and then we'll be dividing this whole by, let me put this in the parenthesis, 28 times 0.1203, and close the parenthesis, and we do that, and we get 1.851. So let me write it. P is equal to 1.851, and the unit that we have it is in atmosphere. Now this is okay by don't take into account the significant figures. So what would be the significant figure in this particular problem? See, over here we have taken 0.25, which is two significant figures. We have 31 degrees centigrade, which is again two significant figure. So the final information should be in the list of the significant figures of the numbers that we've used. So this should be in two significant figures. So as you can see, I really have to put underline 1.8 and then 5. When you round it up, the pressure is going to be 1.9 atmospheric pressure. So this is the pressure inside the ball that we can calculate.